All right, welcome to the next unit we're working on. We're gonna call it Unit 9, and it's essentially going to be talking about proving that shapes on a graph are certain figures, parallelogram, rectangle, rhombus, that type of thing. Okay, so to get there, we're going to start talking about the formulas we're going to need, which are the midpoint, distance, and slope formulas. Okay, so we're going to talk about how to use these formulas on a graph and kind of moving forward. So on a number line, we would know the distance is just how many units between two numbers. And to do that, we would just pretty much calculate the average, okay, or the mean of those numbers. So if my point A was located at A and B was at B, like for instance, if I had a point at 7 and the other one at 18, okay, the number in the middle, the midpoint, is going to be the average of those numbers. So 17 plus 18 divided by 2, okay? Now, if it's on a graph, I have essentially two different number lines happening at once, the x's and the y's. So all I'm going to do is the average of each the x and y coordinate. So the formula looks like this, okay? So the midpoint formula is just the average of the x's. So we're going to label this first point A using points x1 and y1, and point B is going to get the points x2 and y2. And so we're just going to do x2 plus x1 over 2, okay, comma, y2 plus y1 over 2. That's essentially the formula we're going to use, and that's it moving forward. Okay, so average of the x's, average of the y's. All right, so if it's just a number line, we're just going to do -4 plus 9 and then divided by 2. So this is 5 over 2, which is 2.5. Okay, that's the coordinate for the midpoint. Now, if it's on a graph, we have two options. We can just use the midpoint formula, okay? So the midpoint, well, that's terrible writing, okay? The mid, PT for point, okay? So x2 plus x1 over 2, and then y2 plus y1 over 2, average, okay? So this first point gets x1, y1, second point get x2, y2. It doesn't matter which point you pick as the first point. Just be consistent. So x2 is going to be 2 plus x1, which is 7 over 2. And then x2 or y2 is -4 plus y1, which is 5 over 2. So this is going to give me 9 over 2, which is 4.5, and positive 1 over 2, which is a half. So whether you want to write it as a point or you want to put 9 over 2, comma 1 over 2 is up to you, okay? But the other option is to actually use the rise and the run, okay? So I would say if I wanted to go up, I would have to go up 9 units, and then over to the right, we would say from 2 to 7, so over 5, and then I'm going to move half of that amount. So I'm going to go up 4.5, right, over 2.5, and then where those 2 points, where those 2 measurements work, there's my point. And this is going to be the point. You can read it on the graph. So this is 1, 2, right, 3, 4.5, comma, 0.5, right? Those are the two ways that we're going to kind of work on it. That's it. So take a look at the got it question. The endpoints in the number line, we're just going to do -12 plus 4 over 2, which is -8 over 2. So that's -4. And for point RS, we're going to stick with the formula for this. I think it's just easier for this to use the formula. So go ahead and label. And then we're going to use our point. So x2 plus x1 over 2, comma y2 plus y1 over 2. And then we plug in. So x2, the second x is 3, plus the first x, which is 5 over 2. The second x is, or y value is 6, plus the first one, which is -10 over 2. And this gives me 8 over 2, which is 4. And this is -4 over 2, so that's -2. All right, there's our midpoint. All right, so This is the other variation that they could ask, which is kind of finding an endpoint. So the easiest way for me to do this is to essentially just kind of use a leapfrog method. This is pretty simple when you do this. Just pay attention to which is the midpoint. So we know the midpoint is M. So what happens is I'm starting at C, okay, which is some coordinate. I'm then moving to M, which has some other coordinate. Sorry, that is not how I want to write that. M, which has some other coordinate, and then it's moving on to D, which has another coordinate. And so all I'm going to do is take my x value for the C, which is -5, and figure out what I'm going to do to it to turn it into the x value for M, which is -2. And so this means, right, when I start at C, that I have to move over to the right 3 units, okay? So I'm just going to move over to the right the same amount, 3 units, to get to the next point. So if this is +3 to get from C to M, I'm just going to do it again, +3, to get from M to D. And -2 plus 3 becomes +1, not -1. Okay? And the same thing now for the y value. So the y value for C is 7, okay? The y value for M is 1. So you can see that I'm going down 6 numbers to get from 7 to 1. So I'm going to repeat that and go down 6 more, and that'll put me at -5. Okay, so once again, down 6. So once I know I'm here, I'm going to go down 6. So technically, I guess I would want to draw it from the end of the arrow. Down 6, down 6, and there's my point, okay? Which is 1, -5. All right, that's it. So take a look at number 2. The midpoint of AB is this point, 4, -9. The endpoint is -3, 5. So I'm going to go -3, -5. I think I said -3, 5. -3, -5. Over to the midpoint, which is 4, -9. And then over to the coordinates of B, okay? So to get from -3 to +4, we're adding 7. So we're going to add 7 more. And then from 4 plus 7 is 11. From -3 to -9 is going down 4. We're going to subtract 4 more, and that puts us at -13. And there's my answer. Okay. The next one is the distance formula. The distance formula is essentially just the Pythagorean theorem, okay? That's all it is. So all I'm going to do to figure out the distance between 2 points is to count the rise and the run to get from one point to the other one. So you can see from get to A from to B, I have to move over a certain amount, left to right, and then I have to move up or down a certain amount. This amount, right, we'll call A, and this amount we'll call B, okay? Now, this forms a triangle here, so this length is essentially just the hypotenuse formed by this right triangle. So if I do a squared plus b squared, right, that'll get me c squared, and when I take the square root of both sides, I'll end up with the distance formula. A squared plus b squared is now equal to c, the square root of that, sorry. Okay, now technically what I'm doing is I'm taking the second x value and subtracting the first to figure out how far apart they are. Okay, so this formula becomes x2, the bigger x usually, minus x1 squared, and we square it because it's going to come out positive. So even if we did smaller minus bigger, we'll still get the same answer because we're squaring that amount. Okay, plus the same thing with the y's. y2 minus y1 quantity squared. And this is just equal to the distance. Okay, so what's the distance between u and v? So what we're going to do is we're going to write d equals, and we're going to do this 2 ways. Okay, so I'm going to write uv down below so that it reminds me of what points I'm using. So when you're doing this, eventually we're doing what's called coordinate geometry proofs. Okay, we're going to be doing this for more than one line segment. So we want to name them so we keep track of what we're doing. Okay, and so once again, we're going to do square root, and we use the formula. It's x2 minus x1 squared plus y2 minus y1 squared. Okay, so once again, here's x1, y1, Here's x2, y2. And so now I just plug in the equation. x2 is the second x coordinate, which is 4, minus the first one in line, which is -7, so that's going to become a plus. y2 is the second y, that's -3, minus the first y, which is 5, okay, and squared. So we're going to end up getting the square root of 11 squared plus -8 squared. Okay, so if we type this in our calculator, we're going to get essentially 185. And so this would equal the square root of 185. And then to the nearest tenth, okay, so square root, control square root, and then I can go up and highlight, and I get 13.6 to the nearest tenth. Now, normally what you could do is just type in this stuff right in your calculator and hit enter. So I would normally go square root, okay, parentheses, right, 4 minus -7, so there's my +7, okay, squared, plus, and then we're going to get -3 minus 5, so -3 minus 5, and then squared. And there's my answer, okay? So that's normally what I would do just to shortcut that. Now, the other thing we could do, the other way to do this, is just to count the rise and the run. What's the change to go from -7 to 4, okay? And you can see we'd have to go up 7 and up 4 more, so this is +11, okay? And then what's the change to get from 5 to -3? And so this would be going -8. So this is essentially just going to be a squared plus b squared equals c squared, and I'm using those values. So 11 squared plus -8 squared, right? We already know this is equal to 185 because we did the math earlier. Just trying to clean up that 8 for us. And then I'm just going to do the square root, and we'll end up at that same answer. Okay, so I'll let you guys decide how you want to do it. Go ahead and try it for the next one here, okay? And we're gonna skip this part right here. Don't worry about this. Just do the distance for SR. That's it, okay? And so if you're doing the math, sorry for all the silence there, we're just plugging in. So second x minus the first x, second y minus the first y, so 5 squared, -15 squared. This is 25, 225, so 250, so square root of 250 gets us 15.8. Okay, and then if we entered those ones in for part B, does it get the same value? We just check the distance. All right, going over to the third one. Okay, just some quick questions. Do you know how? All right, so here are the endpoints. Can you find the midpoint? Okay, so once again, you're just doing the average. All right, so we're just going to do formula, and then we're going to do x2. So we're going to do -1 plus x1 over 2. Okay, comma for the y values, 7 plus 4 over 2. So once again, it's x2 plus x1 over 2. This is the only formula, by the way, that is adding. The other ones are all subtracting. All right. And so we're going to end up getting, we'll just work sideways so he stays in room here, 1 over 2, so that's a half, and 11 over 2. So if you wanted to, you could write down 0.5, comma, 5.5. All right. Okay, question 2, the midpoint is given as 5, -2. The endpoint is 3, 4. So go ahead and try this one if you want. Okay. So we're going to start with B, which is 3, 4. Going over to the midpoint, right, which is 5, -2. and then we're going to end up at point C. So we're using the leapfrog method here, okay? So from 3 to 5 is plus 2. We're going to do that again for the x's, and 5 plus 2 is 7. From 4 to negative 2 is down 6. So we're going to do the same thing to the y's again, go down 6, and we're at negative 8. And there's the coordinates of point C. Okay? So for number 3, the distance between the points, remember distance formula. Okay, so square root x2 minus x1 squared plus y2 minus y1 squared. So distance, so x2 means second x value. So the second x value I see right here is negative 6 minus the first x value, which is minus a negative 9. So this is going to be plus squared. Okay, and then the second y value is 0 minus the first, which is 8 squared. So this is going to turn into negative 6 plus 9 is 3 squared. 0 minus 8 is negative 8 squared. So the distance is going to turn into 9 plus 64, which is the square root of 73. Now it doesn't say to put as a decimal, so we're going to leave it as that radical right there. And if we check our calculator, okay, and we do menu, number, factor, we type in 73, this is prime. So there's no other prime factors that multiply to give you 73. So it is in simplest form, that's what it tells us. Okay, so slope formula, you should be familiar with, rise over run. So y2 minus y1 over x2 minus x1. All right, that's it. So take a look at point A, right? Y2 is the second y value. So that's 6 minus the first y value is 2. That's just weird how that looks with the minus sign there. So 6 minus 2 over this x2, which is the second x4, minus the first x, which is 3. Okay, so 6 minus 2 is 4 over 1, or just 4. There's your slope. All right, and normally we would write m equals here, m for slope. So same thing for part B. Okay, m equals. So y2 is 5 minus y1 is 6. x2 is 2. I already did it wrong. Do you see it? Oh, I said y, but I actually did x. So y2 minus y1. It's always a good idea to write down the formula for yourself, just because it keeps you honest. You know, you can visually see it and you won't get tripped up. So second y, 2 minus the first y, 3, over the second x, which is 5, minus the first x, which is 1. And so these both turn into negative 1 over negative 1, which is actually positive 1. All right. So second one down here, once again. So y2 minus y1 over 2, sorry, thinking midpoint here, over x2 minus x1. And so this is going to turn into second y, negative 8, minus the first y, which is 4. Second x is 3 minus negative 2, the first x. There's a positive. So this turns into negative 12 over 5. And that is our slope. Okay, now, would it matter if we switch the coordinates around? Would it matter if we consider this to be x2 and y2? Does it change our slope? And the answer is no. Okay, so if you did it this way, you would do 4 minus negative 8, right, over, and now we do the x's, okay? So we would be doing x2, which is negative 2 minus 3. So in this part, we turn the 12 positive, but now the 5 is negative. And it's still a negative 12 over 5. So it doesn't matter which point you've considered to be the point 2, as long as you're consistent, you're stacking those points. So if you notice, the 8 and negative 3 are always stacked over each other here. Okay, that's how you know you're doing your slope formula right. Okay, all right, so let's go to the last one here. Look at our special cases. So once again, y2 minus y1, x2 minus x1. So the slope is equal to y2 is the second y, so that's negative 6, minus the first y, which is minus negative 3. So we change that to our plus positive. And then we do our x2, which is negative 3, minus our x1, which is negative 2. So change that to a plus a positive. So negative 6 plus 3 is negative 3. and negative 3 plus 2 is negative 1, and so we get a slope of 3. Okay, so these two special cases are because we have two of the coordinates the same, okay? So here we have the x's the same, all right? Here the x's are the same, and here the y values are the same. So if the x's are the same, when we do our slope, we're going to do, right, y2 minus y1 over x2 minus x1. So we're going to do 7 minus 4 over 2 minus 2. And when we do this, we're going to get some number, whatever it is. Here it's 3 over 0. And we can't divide by 0, okay? So this slope is actually undefined. And when this happens, when the x's are the same, this is actually a vertical line. So vertical lines, right, are always x equal graphs, and their slopes are always undefined. Now, if we do the y value the same, we do 4 minus, trying to go blue, but apparently we went purple. So now we do our slope value, right? y2 minus y1, x2 minus x1. We end up getting, right, 4 minus 4 on the top over 8 minus 3. And so we get 0 over, in this case, 5. So 0 over number is always 0. So this is a horizontal line when the y values are the same, different x's, okay? All right. This line is always going to be a y equals graph, and it has a slope of 0, okay? So we can keep that in mind. So if you see it on a graph and you can see it's a vertical line, you can just tell me it's undefined. If you see a horizontal line, you can just say the slope is 0. You don't have to actually go about proving it. It's something now we have shown. All right, guys, that is it for tonight. Make sure you finish up the extra questions in the Play Pause video, and have a great month.